Okay, well let's go ahead and get started then. So hello everybody and welcome to a special QP4 webinar. My name is Octavio Corral and I'm the Business Development and Marketing Manager for QP4. And on the call we have the team from Neurala as well as Carlos Cuellar, our QP4 Director. So a little bit of background before we get started. QP4 is a local company here in Juarez and El Paso providing on-demand engineering to help manufacturers and suppliers when quality issues arise. QP4 was created by its parent company, Impulse Supply Chain, after seeing the disruptions that are caused in a supply chain due to quality issues. Now, as part of QP4's mission to always be improving quality, we've developed a partnership with visual inspection AI company Neurala. They're based out of Boston, Massachusetts, and they're on the cutting edge of visual inspection and artificial intelligence. So QP4 has developed a partnership to combine our on-site engineering teams with Neurala's technology to see how we can start to bring this to the manufacturing and maquila industry here in Juarez. So for today's webinar, we have with us from Neurala, Matt Campbell and Erica Gilbert. They're going to tell us a little bit about this technology, how it can be applied in a manufacturing setting, and what it takes to build a good case for visual AI inspections. And after that, we're going to open it up for some questions and answers so you all can start brainstorming and ask questions directly to see how this can be applied at your all's plants. And before I hand things over to the team at Neurala, I'm going to kick it over to the director of QP4 so he can give us a brief introduction into Industry 4.0 and Quality 4.0, and also give us a little commentary in Spanish. Carlos, take it away.
Thank you, Octavio. Good morning, everyone. In our company's journey to get into Quality 4.0 or Industry 4.0, or just to complete that digital transformation process, some of the key elements are cloud computing, big data, virtual reality, augmented reality, blockchain, additive manufacturing, artificial intelligence, machine learning, and IoT or Internet of Things. Today, we will focus in AI or artificial intelligence, a piece of technology not very well understood, but one of the most promising areas to improve manufacturing and quality. Most of the border-zone maquiladoras processes rely on visual inspection for product acceptance. Using AI to make visual inspection more reliable will directly improve our product's quality. That's why we're here today. Buenos días a todos, ahora en español. En el intento de nuestras plantas para ingresar a la era de calidad 4.0, industria 4.0, o simplemente para completar el proceso de transformación digital, algunos de los elementos claves son computación en la nube, big data, realidad virtual o VR, realidad aumentada o AR, blockchain, manufactura aditiva, inteligencia artificial o AI, aprendizaje automático o machine learning, e Internet de las cosas, IoT. Hoy nos centraremos en AI o inteligencia artificial, una parte de tecnología que no se comprende muy bien, pero una de las áreas más prometedoras para mejorar la manufactura y la calidad. La mayoría de los procesos de la industria maquiladora en la zona fronteriza se basan en la inspección visual para la aceptación de sus productos. El uso de la inteligencia artificial para hacer que la inspección visual sea más confiable mejorará directamente la calidad de nuestros productos. Es por eso que hoy estamos aquí. Bienvenidos todos. Adelante.
Octavio, Carlos, thanks so much for the opportunity to present today. Eric and I are very much looking forward to it. And our goal is to demystify deep learning to talk more about how it fits in industrial manufacturing. And hopefully as a result, you all can learn a thing or two about how it fits. And if there is more interest, we're happy to talk. But right now, I'm going to share my screen and presentation. One moment. All right, perfect. So you all have a good sense of quality inspection today in manufacturing. Some of it is done manually with humans looking for defects in different products. Other cases involve expensive machines that have machine vision. In some cases, these two are combined, working to improve quality inspection. But the area that I want to talk to you today about is deep learning and how it can augment quality inspection today. So in this presentation, I plan to level set, give you a definition of machine vision, talk about how deep learning can augment that, and then towards the end, talk specifically about how Neurala's technology, our deep learning, can improve quality inspection uniquely. That will be followed with a few customer stories, along with a demo that will be able to show you how this works in real time. So we're very excited today, and I'll kick things off with what machine vision is. And it's a bit ironic I'm talking about it and telling you guys about it because everyone in this webinar probably knows more than I do about it. But at a high level, machine vision is rules-based and logic-based, which means it is fixed. If you teach it a pattern, it understands that pattern, but nothing more or nothing less of that pattern, which means it falls into issues of variation. Some core tenets are guidance. It's very good at reporting the location or the orientation of a product. Another area is gauging, which really means measuring 2 or more points on a product. Identification is also a big part, being able to read barcodes, OCR, inspection as well, defining and detecting different types of defects within a product. This is all really just, again, to level set on what we view machine vision as, so we can talk more specifically about things it can't do. So what happens when there's variability and deviation in appearance? Or what happens when there's difficulty distinguishing between cosmetic blemishes? And what happens if there is more data to actually improve inspection, but machine vision can't do it? So these are areas where machine vision doesn't really compete. And when you look more carefully at these different areas where machine vision is incomplete, it's pretty obvious that it can be improved for certain use cases. Ideally, we see AI as augmenting machine vision. And this is really how in this Venn diagram. We talked about what traditional machine vision is good at, but deep learning is able to add a new type of skill to that type of technology. So for example, it's deep learning, or what we also call AI. I'll probably go back and forth talking about these two terms. They're synonymous. But deep learning takes on challenging problems with OCR and print. It could be blemish, it could be tough to decipher. AI is good at that. It's also good at deformed and variable feature location, as well as assembly verification, texture and material classification. We call these subjective type surface level defects. These are another areas where deep learning thrives at, as well as complex inspection and segmentation. There are areas in which traditional machine vision and deep learning can do the same thing with inspection and defect detection, OCR, part and feature location counting. But again, there are areas and use cases where traditional machine vision is lacking. And that's where we believe deep learning can come in to augment those types of inspection solutions. So you're probably curious as what deep learning is. And at a high level, deep learning uses complex numbers called binary to learn features on data or images to then take that and analyze images in a production setting. So for example, on a line. And what it's really good at is subjective analysis, which I talked about. Subjective analysis is oftentimes things that humans can pick up or identify, like scratches, blemishes, issues with texture. These are all things that AI is very good at identifying. It's also good at solving specific tasks without being explicitly programmed to do so. So what I mean by that is an AI is able to learn on a certain type of data set and images, but then be able to generalize beyond that and maybe identify a variation of what it already learned. That's super important in manufacturing where there is inherently variation and defects. It's also well equipped to understand anomalies. So in manufacturing, there's a trend today that you guys might be aware of where you can train an algorithm or deep learning on what a good product is, so it understands it very well. And as a result, it's able to understand what's considered bad or a defective product, therefore pushing through the good product and putting aside the ones that are defective. And lastly, deep learning learns incrementally. So this is something that, again, machine vision can't do because it's fixed. Deep learning can learn as data comes in. So if there's new data of what a new defect looks like or a new product comes in, AI can quickly adapt and learn from that. And these are some areas, some real examples of types of defects that deep learning can pick up pretty easily. These are examples of sheet metal defects. It's an open source data set. You can access it yourself. Erica will go on later demoing some of these things. But what you can see here is a variety of defects. On the left here, you can see issues with pitting. And if you look at the very top one compared to the bottom one, there is variance there. Although it's the same class of defect, they're actually a little bit different. Same with the different scratches here. They're not all the same size. They're not all on the same exact part of the sheet metal. So these are really good examples of areas where deep learning can identify these defects. And also examples of where you might have a human in the loop inspecting and finding these types of defects. So all this talk about how great deep learning is for manufacturing, well, it actually has its deficiencies. The first is deep learning requires a ton of data. We're talking about 500 to 1,000 images per class. That's a lot, and it's really tough to find in a manufacturing setting where you might have very, very few amounts of defective product images to work off of. So that's a problem. The second problem is there is a shortage of AI talent. There aren't enough AI engineers and AI PhDs in the world to build these models. And so that, combined with some other variables means that it's really takes a long time to develop deep learning models today. AI deep learning is a bit of iteration. It's a bit of a guess and check. You build a model, you try to achieve a certain performance and accuracy, let's say, but if it doesn't reach that, you actually have to get new data and retrain from the very beginning. So what I'm really saying is the process to building deep learning models is very unpredictable. It could be 3 months, it could be a year. It really depends on the use case and the expectation around performance. So because of this, the total cost to deploy is oftentimes expensive, but also unpredictable too, because you're unsure of what exactly you're going to get out of that deep learning model. So we hear this all the time from customers, we don't have enough pictures of defective product to build a model, or our product changes frequently and it's too hard to update DNNs, or we just can't simply pass on this additional cost to our customers. So for these reasons, it's why deep learning has yet to really take a stronghold in the manufacturing setting. Simply put, it's just really not accessible yet. So this is where Neurala comes in and our deep learning model. Part of deep learning is that it's really, really complex to build. As I said, you need AI engineers, you need AI PhDs. Well, our technology is very intuitive. In fact, I myself, who am not technical at all, am able to leverage our platform Brain Builder and build a custom vision model. So this is actually really important. When you look at manufacturing, you might have an operator who may not be skilled with AI. You might have a QA manager who doesn't know much about AI. We're bringing technology to these folks to enable them to build models that they can deploy to improve inspection on their lines. So one thing we do differently than traditional deep learning is that our technology actually works with much less data, in some cases up to 99% less data. This is significant for two reasons. One, it means that it's much easier and quicker to build a model for production. Two, means that you can use the data where you might not have enough for a specific type of defect and actually use it to effectively make something that can identify it in production. The second area is we've worked very hard lately to get our model to be able to run at the specifications manufacturers require in a production environment, running anywhere between 5 and 60 hertz. Additionally, our technology, our deep learning model, is very good at incrementally updating for new products. Traditional deep learning can do updates. It just takes a lot of time and retraining. So the time and the expense of that makes it not worth it in the long run. And as a result, also, our technology can be delivered at a lower cost. How much? I can't put a number to it. It depends on the use case. But by and large, we're helping customers save costs in delivering deep learning models. So what we've done is we've taken our unique deep learning model and we have productized it in two ways. The first is our platform Brain Builder, which is cloud-based. It would allow a user or an operator to take custom data, upload it, train a model, and then deploy it to a machine. We also most recently have developed a solution that is built for industrial PCs. We realize that a lot of manufacturers are leveraging them in their inspection environments, and we actually have enabled our model to run and work on the industrial PC, which allow for real-time updates and tweaking to make sure the model is running at the performance needed. So where does this fit? Obviously, it could fit in a lot of different places. It depends on the data in a lot of cases. But where we've seen success starts off with food contamination. So there is a use case, we're working with a customer in which X-ray analysis is used to analyze food to make sure there's nothing wrong with it, to make sure that there isn't, let's say, a metal thing in a steak. And so the problem here was this analysis was done manually, and that process was expensive. So what Neurala was able to do was help automate that and save costs for that customer. Another area is with dairy packaging. And so they wanted to improve barcode verification. The problem was the barcodes weren't straightforward. They were a bit difficult to work with, and traditional machine vision had trouble identifying these barcodes. This is where Neurala was able to step in and to automate that process. PCB inspection is something that we're seeing more and more of in the field. Today, PCB inspection leverages these huge inspection machines called AOI machines that leverage machine vision and are good at finding some of the things that I talked about before, but are not good at finding subjective defects. So today they actually have operators on the line to identify those subjective defects. The idea with Neurala is you can plug in our deep learning solution to further automate that process. Now, we're not talking about fully eliminating the operator, but we're talking about improving operational efficiency, making that operator and allowing them potentially to do other tasks or other jobs, making the business run better. And finally, we work with an automation company. One of the things they do is develop these huge machines that they sell to customers to produce different goods, medicine, tobacco products. In this case, we're working with a team to help out with tea packaging. And one of the problems they have is they weren't achieving high enough accuracy. And accuracy matters a lot because their customers need to send out a good product. And if they can't achieve a certain amount of accuracy, they're gonna be losing money on defective product. So Neurala came in to augment their traditional machine vision to improve overall quality of inspection with deep learning. So these are some of the stories where we've showed success. Just because you might have a use case that's not on here doesn't mean we can't help you out. Again, a lot is dependent on different types of data. But now I'm going to pass the presentation along to Erica to run through a demo so you can see our technology working in real time. Sorry, one second.
Great. No problem. Thanks for that introduction, Matt. So I'm a solutions engineer at Neurala, actually a part of the customer success team. So I have a lot of visibility into how our customers are solving problems. So if you have questions around that, as we get to the latter portion, I'm happy to do that. I'll make sure that I pull up my correct screen here. But, I am an expert in how to use our product, but what's really key, and I hope everyone can see my screen, is that good?
Yes, yeah, I see it.
Great. One of the key tenets, as Matt mentioned, is around usability. And so we want to enable anyone who wants to test to see, create a feasibility study of what's possible with AI, the ability to use our online platform to do those initial tests. So one takeaway that you should have today is that anyone could get up and running and testing in our platform while also getting really quick results because our platform is using our patented technology. So one of the features of that technology is that it learns on less data, but it can also learn with just using what acceptable product images look like. So that's what I'm going to walk you through today. So I'll actually build a deep learning model using our patented technology in our platform from beginning to end using a very small subset of data. So I'm going to go ahead and start doing that now. As you can see here, there's a really easy to use interface that gives me a snapshot of the data that I'm working with for a given product. In this case, we're working with data around understanding bottle caps and if there might be anything abnormal within them. So what I'll do actually is upload first 20 images that represent normal. And when I press this start upload button, what is actually happening is that the deep learning model is actually learning what constitutes normal and acceptable from those 20 different images. So while it's fairly lengthy here, we're also uploading and hosting them into the cloud. So it shows you just how fast the deep learning model is able to learn. So now I'm actually going to upload what would constitute something that is defective. And in this case, we have to use open source data. So I had to manufacture those defects digitally, but some of the examples include, and I'll show you here in a minute, you know, rust, missing bottle cap, metal debris, those types of things. So let me just show you what those look like. So here you can see there's something black on the actual bottle cap. Here you can see there's a missing color is incorrect. There's metal debris. In this case, the bottle cap is missing completely. And as I uploaded those images, it fine-tuned what the model understood as normal, but more importantly, it tested the model's performance to see how well it would capture those in a real-world environment. But as you can see here, the images themselves, we obviously want to focus in on just one area and not look at the larger picture. So I'm going to go here, and you can see it's sort of moving me along a process here. I'm going to create a focus for the neural network to learn. And this is using our region of interest tool. So here, I'm just going to create a box around that bottle cap. So I know that on the line, an image is taken at this moment for every single bottle cap. And then I can just verify that the bottle cap is mostly in the frame for each image. And now I'll retrain focused only on that exclusive area. So the model will learn and be a little less confused with potentially all of the background that has been included in the initial training of the model. And so what we see here is that we get a sense of, you know, what is the performance? So how many times did the model correctly identify an anomaly, and how many times did it correctly identify what is normal? So in this case, we're seeing a lower sense of accuracy here. It had a false negative for what would be considered an anomaly as a normal image. So while that makes me feel comfortable that this is a solvable problem, I'd like to fine tune and optimize that performance for this specific data. So as Matt mentioned, deep learning really is understanding the features in images the way a human would. So what I'm actually going to do is press this optimization button. And what that does is look at the architecture of the deep learning, also commonly called a DNN, a deep neural network, and picks the one that understands the features of the data the best. So in some cases, a lot of times manufacturers are working with grayscale images. There are neural network architectures that understand that better. Or for example, it could be like in this case where it's very color focused, so it's understanding that better. And now in this case, we see that it was able to identify all of the different components correctly. So every time there was an anomaly, it identified it, and every time there was a normal image, it identified. I can actually drill down and see exactly what it did here by looking at the images. In this case, they're all correct now, but if I were getting more incorrects, it could help me understand what the model is not understanding visually so that I could add additional data to that model and increase its performance going forward. But really the goal here is to instill confidence that AI can solve this problem on the manufacturing line. Then I'm given tools to test my model's performance. So in this case, I can actually upload different images of product that the model has never seen before and verify that it's, you know, doing that correctly. And then finally, most importantly, I can deploy this model and get up and running testing. So with the cloud-based version of our platform, obviously this is available at a versioning method here via our RESTful API. And then it's also available to embed on a device using our SDK. But we also have mechanisms, as Matt mentioned, that work directly on the IPC so that you do not have to interact with a cloud-based version of our platform. But beginning to end, I was able to test and validate that I can solve this problem with a very limited set of data in order to help increase the ability for me to actually get to 100% visual inspection without requiring an operator. But do that in just a few minutes rather than the hours it takes other folks typically to run that full process.
Perfect. So I will continue with the presentation. So at this point, if you're interested, you're probably trying to figure out, will this work for me? How do I get access to Neurala's technology? And as long as you have a camera that can pick up 50 images of an acceptable product with 5 to 10 examples of a defective product, and if that's tough to do, you can simulate that, you can fabricate it in some way. But if you have that and you have a use case wrapped around that, we can help you understand feasibility of that use case pretty quickly. And using that data, if we need to get an NDA in place, that's totally fine. You can build a model very easily, like Erica just showed, with our technology. So very quickly, we're able to work with you to have the data that you have and see if it works for deep learning and it matches the expectations that you have. So a bit about Neurala and who we are outside of what you learned today. We are a custom deep learning company, which really means we make the devices and the applications that ingest video or images smarter. The 3 people you see here are co-founders. They had actually done work with NASA, and I think around 2010, to improve perception of the Mars rover to be sent to space and to collect images and artifacts of the red planet. From this experience, they were able to commercialize the model that you saw today. One that learned off less data, one that could learn continuously, and one that was built for an edge environment. To date, our tech is on 56 million devices across the world, including cell phones, robots, machines, and drones. And what you've seen today is our focus to improve industrial inspections for manufacturers. And that has taken most of our energy, and we're really excited where we've come today to solve some of those problems. So with that, I really appreciate your patience through this webinar. We're happy to open it up for any questions.
Thank you very much, Matt. That was great. Very good information there. If anybody has any questions, you all can submit them through the question and answer model, and as well as the chat, or just raise your hand through the Zoom application, and we can put your audio here. We did get one question first here. Eric, I don't know if you can see that one.
Yeah, so their question was around, what is the cost to actually try out the platform? Obviously, we want to prove that something works for our manufacturing customers before we get into any sort of cost associated with that, which is why it's great that we have Brain Builder available in the cloud. It's a straightforward, lift for us to be able to open that up for our clients for an evaluation to test if a use case will work using our technology.
We have another question there from Hector Lugo. Is it necessary to develop algorithms?
Yeah, so the benefit of the Neurala technology is that what you just saw was actually developing an algorithm on the fly. So you don't need to have AI competency to build different types of neural networks. You can rely on the fast learning capability of ours to do that on the fly very quickly and easily.
And then we have the question from Hendrik Rebine. Can you apply this to a bigger, more complex part to check?
Yeah, so I think that gets into questions around workflow. I think as you saw, Matt spoke to the PCB board inspection use case. And this type of technology, as you saw, the imagery was very consistent and we were focused in on one small area. So if your imagery falls into those same requirements, then we can focus on one small area of that. If you need to evaluate for the entire area, it really just depends on the data and the use case, and we'd be happy to go more in depth on and evaluate and give you some feedback on what we think is actually possible.
Okay, great. Another question from Hendrik. Are there any integrations that will allow automated analysis, like from any other data gathering system through an API? I'm assuming he's referring to the data coming in from somewhere else.
Yeah, so as part of what we've set up for our manufacturing solution, you do get two software components to install on an industrial PC. And as part of that, you are able to set up and configure how you would like those models to interact with the machine. There aren't specific APIs that take that data and would work together. But what we do is pass the information on what the analyzed response from any given image for you to do any additional analysis with and combine.
Okay. There was a question that came in from the chat earlier. Jose Rodriguez asked, the sample that Matt showed had a flat surface. Does it also work on round surfaces?
So it really is around the visualization of how you teach and train your neural network. So we work exclusively with 2D visual data. What that could mean, though, is that there are 3D representations of some objects. So for example, if you were looking at a flat ornament versus a round one, there are ways to create an image that can then be analyzed as a flat image. And so that's the ideal workflow in which a neural network or a deep learning model could evaluate for those types of surface defects.
Let's see. Daniel asks, could the resulting model be embedded into any code or application?
So the way that we have there are always going to be different ways to skin that cat. What you saw today with our cloud-based platform, you can take the model that you've developed and embed it using our SDK. So put it directly on the device. And that is for Linux, Android, and iOS. We actually have a companion application that you can download in the App Store today if you'd like to test that out for free. In addition, as part of the work we're doing for creating an on-premise manufacturing solution, that model is available through your industrial PC architecture so that you can work with sort of your own system and how it's set up with your PLC.
Okay. Great. Let's see, next question here. In contracting with Neurala, are there different levels of competence locally? Can we buy in, get set for a machine for a product, and later go deeper and develop our own models for other products? Not sure. Nice.
Yeah, I think the heart of that question is trying to have a set of models that might be available out of the box to get started, and then, you know, potentially augment or create new models going forward. And what we've seen is that every company is so different, every product is so different, every type of defect that you might be looking for is so different, that we don't provide those generalized models out of the box. But because you can develop them so quickly with just 50 images, it sort of negates that need to have a base level set of models available. We do have a customer success account manager assigned to every customer who could help suss out, you know, what models to start and develop for your team.
Okay. Let's see what else. Olinto Lesure has a question. Is it considered the temperature environment on the product or parts we're measuring on this new technology? Not sure what he's asking there in regards to temperature.
So, I mean, we have seen that other sensors can give valuable information when you're considering a part defective. You know, we worked with customers on creating a more integrated solution where that feedback around the sensors is part of an overall solution we provided. But that's more of a custom workflow. But we'd be happy to talk to you and learn a little bit more about how you'd like to use temperature in tandem with a visual component.
Okay. And then Arturo Diaz asks, the pieces, evaluation pieces should run in a conveyor. So do they need to run in a conveyor? And how many attributes can he, I'm assuming, can he learn at the time? So I guess it's a question in regards to, can the part be on a conveyor, as well as, yeah, how many different attributes can you pick up on a single image?
In theory, the part can be on any sort of system. What you really want is a very consistent image capture process, so that the deep neural network can learn you know, many attributes at once. I think there isn't, how you set up in traditional machine vision, you don't necessarily set the attributes first. What you do is, you know, label on the whole what you're looking for. So what you saw me teach my deep learning model in the demonstration was learn that this is normal, and then fine tune what is defective. But that really can be anything that you decide. So in some cases, what we see our customers do, since they don't have a lot of defective data, what they'll do is actually build a model that just analyzes for acceptable or defective. And then as they collect the data of what defective looks like, then they'll use our same platform to build a model that is able to identify all of the different defect types.
Okay.
Fabio, if I may, I would like to say something in Spanish. A todos los participantes que se sientan más a gusto haciendo sus preguntas en español, adelante, las pueden hacer en español. Aquí entre Octavio y yo las podemos intentar traducir para Erika y Matt, aunque creo que ellos también hablan algo de español. Así que adelante, con confianza.
Gracias, Carlos.
Bueno.
Similar question, I think, that we just asked, how many different measurements can it take from the same item? So
Yeah, so the AI is not, specifically deep learning is not successful when it comes to measurement. So that's something where traditional machine vision handles measurement really, really well. So we wouldn't advise pursuing our solution if those are the types of things that you need to solve for. But if you need to solve for those types of things, plus you're also looking to add intelligence around a more subjective type analysis, then that's where our solution would shine and add value and hopefully increase the yield of your products.
Great. Daniel asks, what is Neurala's business model? Is it a one-time payment for a model, or is it paid in a monthly/yearly basis?
I'll defer to Matt to answer this one.
Yeah, I can answer that question. And it's a good question, and it depends on how you want to use Neurala's technology. So some clients want to build a model in the cloud with Brain Builder and then deploy it with our software development kit to the actual machine. The cloud is a yearly subscription that you would pay for, and then you would pay per SDK license to the machine. In this case, it's most likely an SDK license per camera. And that's a 1-year license, but it does have a maintenance cost. So if you wanted maintenance in year 2, it would be a percentage of that initial cost. The other way to leverage our technology is on the industrial PC, which is a one-time yearly cost that year 2, you would pay, again, a portion of that license for maintenance. So that's how it works out. And if you're interested in learning more specifics about that, feel free to email me right here at mattc@neurala.com, and I can tell you more about how it would work for your specific use case.
Okay, next question we have, what's a realistic accuracy rate that can be achieved, assuming unlimited pictures are available?
That's a really good question. And the unfortunate answer is it's always going to be, it depends. So it depends on the use case itself, the data of what you're trying to identify. We've seen a range of accuracies with different projects we've worked on. What we also understand that a human's performance is typically at 80%. So the goal is for the AI to ultimately, achieve more than 80%. We have seen accuracy levels, as you just saw, with the very small data set that was very high. But once you take that data and put it on the machine, then you're going to see the results in a real world scenario. And the benefit of a technology like ours is that you can then add new knowledge when potentially it encounters edge cases that it hasn't seen before and, maybe misses. In addition, there is also a trade-off typically where deep learning in general, there's a saturation point in which the learning will progress no more, even if you add more images, which is why it's really critical that our technology learns on much, much less data. So you don't need thousands of images, you need hundreds. And in our case, we'd require just 50 to get started.
Okay. Let me see, I have a question from another one from Hendrik. Could you also check for correct builds as for a part/product that has multiple variances, e.g. linking your production schedule with similar? Not sure if I understand. Could you also check for correct builds as part of a product, multiple variances?
Yeah, I believe this is possible, but we would want to test and also see what the data actually looks like. We have talked to customers where essentially you train the AI with all of the different variants of what a correct build looks like, and then it's able to identify if there is something that is outside of that. But once again, it always depends, and that's another reason why having a platform that's open and available for you to do testing is so key and critical.
Great. Question for Alfonso Hernandez. Can the system be a combination of digital inputs and visual indication? So I think that might be a question similar to the temperature one, I assume, where it's an additional piece of information coming in.
Yeah, sensor fusion is something that can really help increase the level of accuracy or confidence in what the AI does. But typically what you would want to do is take the analyzed score from the AI and incorporate that into your workflow.
Hector Lugo asks, how is this AI, how does the AI and machine learning help in a manufacturing environment, for example, in automotive components? I guess they're thinking if there's use cases you all have encountered or have ideas of how it can be used for automotive components.
Yeah, a lot of what we showed in the use case slide that Matt walked through also applies to any component part for automotive. So we've also looked at surface defects being identified on calipers as part of a brake system. Another example of a project we've worked on is looking at, this was more of a custom workflow, but identifying that all of the pieces for assembly in sort of seat belts as part of the kitting process were the correct items in that kit. So absolutely can be done. And all of it is really around automating and making the task for the human much simpler.
Great, thanks. I have a question for myself. What do you recommend to everybody for the initial data gathering of pictures? In terms of, say they're there next to their lines, what would you recommend they do to set up to get something that's at least testable in the brain builder system? So in terms of, I don't know, cameras, tripods, lighting, what should we be looking for there?
I mean, the three are the keys are really just around consistency. So ensuring that you have lighting in a very consistent manner, ensuring that the framing of the product is very consistent, as much as possible as you can. All of those things, because then when it's more consistent, the neural network is able to pick up on the features of what that object is exactly. And if there is more variation, the more images the model needs to truly understand what that product is.
Okay, and then just one last question here from Jose Rodriguez. He just wants to confirm if it can or cannot work on color variation. Which is a good question.
Yeah, so in the example that I showed, we were able to identify different, essentially unacceptable products that had different colors as part of it. So depending on the problem, it's possible that AI could help, but it's also possible that traditional machine vision could handle this just as well. So it really depends, but
okay,
it's possible. So
great. We had, let me see, we had one more question from somebody, but okay. I think that's all the questions for now. If you all have any other additional questions, feel free to email them there to Matt. His email is on the screen. But if there aren't any more questions, then that concludes our webinar. Carlos, I don't know if you want to say any closing comments. Say thank you for everyone for coming.
Sure. I just want to thank everybody for attending this webinar. We're really trying to get all this knowledge required so we all in the border zone maquiladora industry understand and have a good use of that technology. We are very serious on getting into quality 4.0, industry 4.0, and this is just one of the pieces. And we would like to thank also Neurala for all the help. Thank you, Erica. Thank you, Matt. And gracias a todos por atender este seminario. Muchas gracias. Hasta luego.
All right. Thank you very much, Erica and Matt. Thank you for your time today. It's extremely educational. I think we're all excited about the possibilities of applying this technology on a line setting. All righty. Well, thank you very much, everybody.
Thank you, guys.
We'll
We
follow
appreciate
up via email.
so much.
We'll also send out a recording of the webinar after it's complete. All righty. Thank you very much. Take care.
Take care.